Fourth grade lesson 5.5 is prime and composite numbers. Our essential question is, how can you tell whether a number is prime or composite? We first have to figure out what is prime and what is composite, and then how can we tell? So to determine if a number is prime, we need to look at its factors. So let's talk about the factors again. Let's review. Factors are the numbers that you use to build a product. For example, if I have the number 12, what numbers multiply together to give me 12? Well, I have 1 times 12. I could also do 2 times 6, and I could also do 3 times 4. Remember, these are the factors that build 12. So we need to draw on that knowledge about factors. We will learn that prime numbers are the numbers that only have one set of factors. They only have one set of friends, and that is it. And it is 1 times itself. Okay, so I'm going to start by using this to help us understand what prime is and what composite is. Once we understand what it is, then it's easier to find out whether something is prime or composite. And knowing these things just helps us as we get further into math, knowing when we've reduced things as far as we need to reduce them, when we can calculate or factor something out. Having the control of these numbers and the understanding of these numbers works to our advantage. So that's why we learn this. Let's start. I'm going to skip 1. 1's kind of a tricky one, so I'm going to just go with 2. Let's look at the number 2, and let's talk about the factors of 2. I could do 1 times 2 to get 2, right? And that's it. That's all I could do. I can't do 3 times 4 or anything like that. These are the only factors, the only friends that 2 has. He's kind of a loner. Only friends that he has. So for that reason, because his only factors are 1 and himself, he is a prime number. Let's look at 3. Oops, I want a pen for that. 3. 1 times 3 makes 3. Is there anything else that makes 3? No, right? That's it. Nothing else builds 3, so that is a prime number. What about 4? Let's look at 4. 1 times 4 makes 4. We always know that 1 times itself. Identity property of multiplication. 1 times itself. Whatever number it is itself. So we always know that's going to work. Is there any other way to make 4? Well, 2 times 2 will do that, right? Oh, ding, ding, ding. He's got another set of friends. He's not such a loner. So this is a composite number. So prime numbers are the loners. Their only factors are 1 in itself. And composite numbers have other friends too. That's all they are. So let's look at 5. How can I build a 5? Well, 1 times 5 is 5. 2 times nothing. 3 times nothing makes 5. 4 times nothing makes 5. That's it. If the only factors for 5 is 1 times 5, then that is prime. What about 6? Maybe by now you can kind of guess whether 6 is prime or composite. Let's see how you did. I know 1 times 6 makes 6. Anything else? Yeah, 2 times 3 makes 6, right? He has another set of friends, so this is a composite number. That's all prime and composite are. Does he have only 1 in himself as factors, or does he have another set of friends composite? I put this here because this is something you're going to keep using to help as we get to higher numbers, right? Why don't we use these rules? Because this will come in handy, especially as we get into the higher numbers, right? Right away, we know if the number is even, 2 times something will equal that. So I can go through here and say, oh, okay, well, 2 times 4 is 8. Oops, that's not the one I wanted. I wanted the highlighter. There we go. 8 is composite. 2 times 5 is 10. That's composite. 2 times 6 is 12. That's composite. 2 times 7 is 14. That's composite, 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 composite. Let's see. Divisibility rules. The sum of the digits is divisible by 3. Well, this is divisible by 3, isn't it? Because 3 times 3 equals 9. So 1 times 9 and 3 times 3. Oh, I did it again. That's composite. That's what I meant to do. The sum of the digits. We have 1 plus 1 is 2. 3 doesn't divide into 2, so 3 is not divisible. This is not divisible by 3. 1 plus 3 is 4. Not divisible. 4 is not divisible by 3. 1 plus 5 is 6. 6 is divisible by 3, so 15 is divisible by 3. That means it has the factors of, maybe I'm going too fast here. Let me just kind of point this out. We know 1 times 15, and because this is divisible by 3, we also know 3 times something. It happens to be 3 times 5. So it has another set of friends. So what I was doing was just going through and quickly using this tool to eliminate out all of the ones I know have another friend, other than 1 times itself. Now I can just double check all of these. 7 is 1 times 7 and nothing else. So that would be prime. There's nothing else that builds a 7. No other factors build a 7. 11 is 1 times 11. Nothing else will build that. Prime. 13, 1 times 13, and that's it. Prime. 17, 1 plus 7 is 8, so 3 doesn't divide into 8, and none of the other rules apply. It's not even, so prime. 19, 1 plus 9 is 10. That is not divisible by 3, and it doesn't follow any of these other rules over here, so prime. So the first set of prime numbers up to 20 is 2, 3, 5, 7, 11, 13, 17, and 19. Those are kind of the ones I let kind of sink into my brain as I got up into those higher levels of math at 6th grade, 7th grade, 8th grade. Those I ended up kind of memorizing because it became helpful for me for whatever I was doing. I would hit a point and go, oh, well, that's a prime number, so I can't reduce that anymore, or I can't factor that any differently. That's a prime number. Afterwards, after 20, I didn't memorize the primes after that because I just used divisibility rules. My brain didn't have the capacity at that point to worry about memorizing primes past 20, but there are primes past 20. There's quite a few of them. You can use this tool to help you find them. Okay, so now you've had my explanation of what primes are. Let's go ahead and let the book kind of explain it too, because maybe that will make more sense to you, or maybe my explanation helps with you and this just helps it even further. We'll unlock the problem. Students are arranging square tables to make one larger rectangular table. The students want to have several ways to arrange the tables. Should they use 12 or 13 tables? Then we're going to use a grid, which we had used in some of those previous lessons, to provide possible ways they can do 12 and 13 tables. We'll draw all the possible arrangements of 12 tables and 13 tables, and we'll label each drawing with the factors it modeled. Well, what are our factors of 12? Let's start there. I have 1 times 12, which is what they've shown here. 1 and 12 gives me an area of 12. I have 2 times 6, so I could do 2 down and 1, 2, 3, 4, 5, 6 over 2 and 6 gives me 12. Anything else? Oh, sure, I can do 3 and 4. Those are factors of 12. So I could do 1, 2, 3 and 1, 2, 3, 4. And that gives me an area of 12. That's it, right? We've learned that as soon as I hit this point, the next number down here would be 4, but it's already there. These are my factors of 12. He's got this one that all products have, and then he's got some other friends. He's composite. So factors of 12 are 1, 2, 3, 4, 6, 12. Let's go ahead and write that there. 1, 2, 3, 4, 6, 12. What if the table is there's 13 tables? I can do 1 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think that's 13. I may have messed up there. No, I didn't. I had it right. Okay. I can do 1 and 13. Is there any other way? Any other way I can multiply any other factors of 13? Not 2 times anything, not 3 times anything. No, there's no other way. This is his only factors. This is the only configuration I can do with 13 tables. That's it. I can't configure it in any of these 3 possibilities. I can only configure it one way to have it all even like that in rectangular form. So 13 is a prime number. A prime number is a whole number greater than 1 that has exactly 2 factors, 1 and itself, and that's it. The loner, right? I'm going to even write that there. The loner. Sad face. A composite number is a whole number greater than 1 that has more than 2 factors, like 12 did over here. It had 1 times 12, of course, but it also had 2 times 6. It also had 3 times 4. It has friends, more friends. So the factors of 12 we found out were 1, 2, 3, 4, 6, 12. 1, 2, 3, 4, 6, 12. Lots of friends. Factors of 13, just 1 and himself, and that's it, all by himself. 12 is a composite number. Not enough room to put there. And then 13 is a prime number. Primes are loners. Only 1 times himself will build him, and composites are lots of friends, lots of factors. Okay, so the next example, divisibility. You can use the divisibility rules, which I took a picture and put here. This is from page 206 in your book. You might want to dog-ear that page, fold over the top corner of page 206 where I got this from to help you through your lesson, or just flip to that page when you get to Think Central to use that as a tool for you. We can use divisibility rules to help tell whether a number is prime or composite. It might be a quick tool to find out right away. If a number is divisible by any number other than 1 in itself, then the number is composite. Something to keep in mind, this got cut off here, but it's in your book. The number 1 is neither prime nor composite. It's neither. It doesn't fall into either category. It's the only one that doesn't, since it has only one factor, 1 times 1, right? It has just one factor. So you'll notice in that very first part of the lesson, I skipped number 1 and just went straight to number 2 because 1 is neither prime nor composite. But afterwards, 2 and above, you can identify whether they're prime or composite. They want us to tell whether 51 is prime or composite. And it's kind of a big number and hard to tell. It's odd, so I know it's not that. Is it divisible by 2? No, because 51 is an odd. Remember, any number that ends in 0, 2, 4, 6, or 8 is even, and any number that ends in 1, 3, 7, 5, 7, 9 is odd. This ends in a 1. It's an odd number, so that doesn't work. So no, it is not divisible by 2 because it's an odd number. Is it divisible by 3? Oh, well, let's go to the 3 rule. The sum of the digits is divisible by 3. Sum of the digits, 5 plus 1. 5 plus 1 is 6. Well, 6 is divisible by 3. 3 times 2 is 6, right? So that means that 51 is also divisible by 3. So yes, it is. And as soon as I find out there's another number that can be a factor of 51, then I don't even have to find out the rest of them. It doesn't ask for all of its factors, not like the previous lessons. It's just asking you, is it prime or is it composite? Prime meaning, does it have just 1 times itself and that's it? Or does it have another factor in there? And as soon as you find one other factor other than 1 in itself, you can automatically say, oh, there we go, it's composite. There's another factor there. 3 is a factor. 3 times something, I don't know what. And you don't even have to figure out what. They're not asking you that. But if your brain's like, hey, I want to know what. I know it's divisible by 3 because the divisibility rule, but please just show my brain. Okay, let's do our calculation. Remember, we ignored this part. So 3 times what number gets me as close to 5 without going over? 3 times 1. That leaves me with 2. And 3 times what number gives me 21? 3 times 7. Dun, 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 dun. There it is. So it's 3 times 17 is another factor. Are there more factors of 51? Possibly. I don't know. They didn't ask me to find all the factors of 51. They just asked me to find out if it's prime, a loner, or composite. Has other friends. And it has other friends. 3 and 17 are other friends. Okay, and here we've made it to the Sharon show. So we've covered the lesson, and we're just going to give our brains some practice at this, see if we can make everything fall into place. First, they want us to use the grid to model the factors of 18 and tell whether 18 is prime or composite. Okay, well, obviously we know that 1 times 18, so this is 1, and then I'm going to count out the 18 across here. Okay, 1 times 18, there are 2 factors of 18. We know that every time, right? If that's the only ones, it's prime. If there's more friends, composite, right? Let's do 2. 18 is an even number, right? So we know that's divisible by 2. 2 times what number is going to give me 18? 2 times 9 does. If you know your multiplication facts, that was easier. If not, you used your grid. 2, 3, 4, 5, 6, 7, 8, 9. But I think by now you're recognizing how helpful it will be to memorize your multiplication facts 1 through 10. Been very helpful so far. Okay, anything else? Let's see. Is it divisible by 3? 3 would be the next one I check. Well, let's check. 1 plus 8 is 9. And 9 is divisible by 3. 3 times 3 is 9. So 18 is divisible by 3. 3 times what number? Well, let's see. 1, 2, 3. 3, 6, 9. 3 times. Oh, I need 18. What am I doing? Erase, erase, erase. Okay. 3, 6, 9, 12, 13, 14, 15, 16, 17, 18. 3 times 6 is 18. Okay, there's factors. 4 is 4 does not go in 18. 4 times 4 is 16, and then 4 times 5 is 20. That skipped right over. I know that 5 doesn't divide into it because it doesn't end in 0 or 5. And is it divisible by 6? Well, I already know this because here it is. It is divisible by 6, but it's just going to be 6 times 3. So now I'm looping back around on my factors. So all of my factors are 1, 2, 3, 6, 9, 18. 1, 2, 3, 6, 9, 18. And so 18 is composite, right? Because it has more friends. Other than 1 in itself, it has other friends. So that is a composite number. Tell whether each of these are prime or composite. So we're going to look at each of these numbers, and as soon as we find any factor other than 1 in itself, then we know composite, right? So we're just being the detective to find one other factor if possible. Does 11 have other factors besides 1 in itself? We know 1 times 11. 1 times 11. It is odd, so 2 won't work. 1 plus 1 is 2. 3 doesn't divide into 2. It doesn't end in a 5 or a 0, so not that. It's to be divisible by 6, it needs to be even, and it's not. To be divisible by 9, well, I already know 9 times 1 is 9, and 9 times 2 is 18, so I've skipped right over it. So that's it. That's it. No other friends. That's it. He's prime. Let's take a look at 73 for question number 3. 73, what are his factors? Well, obviously we know 1 times 73. Right? Obviously, identity property of multiplication. 1 times anything, any number is itself. It is not even, so 2 won't be, it's not divisible by 2. The sum of its digits, 7 plus 3, 7, 8, 9, 10. 3 doesn't divide into 10 equally, so it's not divisible by 3. It doesn't end in 0 or 5, so it's not divisible by 5. It is not even, so not divisible by 6. The sum of the digits is divisible by 9. 7, 8, 9, 10. 10 is not divisible by 9, so it's not divisible by 9. It's looking to me like 73 is also a prime number. Those are his only friends. How sad for him. Prime number. Oh, so sad. Sorry about that, 73. So you could see now, I'm hoping you're seeing like, oh, okay, I see why you keep telling me that page 206, that little graph is helpful, super helpful. You're going to cut that out and save that for your next year too, and the year after that, because I'm telling you, I have referred to this many times when I worked in 6th grade math, and when I worked in 7th grade math, and when I worked in 8th grade math, and probably when you get in and do your high school math as well. Let's take a look at 69. What are my factors for 69? Okay, well, I know 1 times 69 for sure. It is not even, so 2 won't divide into it. Let's check the 3 rule. The sum of the digits is divisible by 3. 6 plus 9. 6 plus 9 is 15. Oh, 3 times 5 is 15, so 15 is divisible by 3, so that means 69 is divisible by 3. I don't know times what, but it doesn't matter, right? They're not asking me what the other factors are. They're just asking me, does it have other factors? Composite. If your brain must know, if it's like, wait, I want to know what it is. Okay, 3 times 2 is 6, 0. And 3 times 3 is 9, so it's 23, in case you really needed to know. But this lesson doesn't ask you to tell them that. And finally, the last one, 42. We know 1 times 42 is a set of factors. And have a look. It is an even number. It ends in 2. Any number ending in 0, 2, 4, 6, or 8 is an even number, and it's even, so that means it's divisible by 2. Anytime you see that even number after the number 2, you know right away, composite, he has other friends. I don't know who they are. I just know that 2 is one of them. There's probably more. In fact, I think 3 is divisible too, because 4 plus 2 is 6, right? 6 is divisible by 3, so that would have worked too. Again, it doesn't matter. This lesson isn't asking me all the factors. It's just asking me prime, only one set of factors, one in itself, or composite, he's got other friends. Even if he has one other friend, that's it. Okay? I hope that made sense to you. I hope that helps you. Dog ear page 206, use this to help you and see how you do on Think Central.